Good morning, everyone. This is Rich Medairos with Taco Comfort Solutions, and we're happy to kick off our HSS software heat pump presentation today. I will be the moderator. Brett Zerba is going to be the presenter. So Brett, just say hi and make sure I can hear you okay.
Hi, Rich. Good morning, everybody, or good afternoon. Hopefully you can hear me, Rich.
Yep, I can hear you loud and clear. So on behalf of the Taco family of companies, I would like to welcome everyone to today's presentation. We have a few housekeeping items to go over. The first one is that you guys will all be muted, and if you have a question, if you could type it into your question box, I will be monitoring the questions, and periodically I'll interrupt Brett and ask him some pointed questions. We also have some handouts. If you look under your control panel, there should be a little button there for handouts, and you can see we have 4 handouts that you can download for your use. You can also, because we are recording this broadcast, I believe you need about 24 hours. So tomorrow sometime, the broadcast recording will be available, and also the certificates for your professional development hours will be available. You will receive an email from the GoToWebinar company. So with that, in a moment, I'm going to turn it over to Brett. But before I do that, if you guys could click on where you can wave your hand so that we can test to make sure that all of you can hear us out there and that you can see the screen. What you should see is Brett's introductory slide for his PowerPoint presentation. So we've got lots of hand wavings out there, so it looks like we're in good shape. So I believe I've covered all of the initial items, Brett. If I've left out something, please let me know. But let's take it away and check out your great presentation.
Thanks, Rich. Hi, everybody. Again, my name is Brett Zerba. I'm an applications engineer with Taco. And Rich, you covered everything. Great job, as usual. So let's get started. So this is our Taco Tuesday session, and a few sessions ago we did a presentation on the HSS software. So today's presentation is going to be a little further advanced, but it's going to be how to design or put together an actual design for a system utilizing the software, the HSS software. I've chosen a heat pump project. There's obviously other types of projects out there, but this is the type that I've chosen for today's presentation. So if I open up a couple other files here, so I'm going to, us together, actually mostly me, we're going to do a heat pump, the hydronic portion of the heat pump design. Okay, we're going to show you how to connect the coils and the piping and the mechanical room stuff and whatnot for a 5-story hotel with 6 rooms on each floor. Relatively small, but nonetheless, obviously you can make a lot bigger projects, but this will get us through in an hour. Okay, so there's a elevation view of the project, and here's a plan view, right? You can see the different units, right? There happens to be 3 units. So it's you know, I think most of us it kind of makes sense what you're seeing here, some stairways at each end of the hallway. And just think about this being 10, 12, 14, 20 units long on both sides or something. But nonetheless, you can see the different units here, right? In the corners, I have an A and 2 A's on one side, 2 C's on the other, and 2 unit B's in the middle. So that's kind of the project we're looking at. So again, to reiterate, it's going to be a 5-story building. I'm going to utilize a cooling tower and a boiler. I will show you with the software, you could use some other components like a ground source, a well of some sort if it happened to be that type of project. But this one we're going to use kind of a traditional type of setup. I think most of us can go with that. And by the way, if you ever did do a heat pump project and you didn't have electricity, let me clarify that. And the heating portion of the heat pump was electrical, right? There are some parts of the world / country / North America that have electrical heat pumps for the heating because they don't really need too much. You would still have to put the boiler in there in order for it to calculate a little bit. So you'd have to dummy it up, and I'll explain that as we go. So, and here's just the load. So if you remember from my first presentation, one of the pieces of information that you have to put into the software is the load or size of the units. So I have 2 unit A's at 36,000 BTU. So somebody did those calculations. Maybe you estimated them. Maybe you had a load calc done, carrier HAP or whatnot. There's different programs out there. United States Building Council has one as well. Unit B has 24,000. Unit C has 30,000. Just so they're a little different, and you can kind of see the differences there as we go. So I'm going to open up my program. Hopefully everyone recognizes it here. Again, that's the HVAC Solutions, TACO Hydronic System Solutions program. It does have to reside on my computer, so I had to download it from the TACO website in order to use this program, so just keep that in mind. You can see all of the Windows functions up here, so let me get started right away. So I have to, the first thing I like to do when I'm doing the design is draw the mechanical room, right? And in this case, the cooling tower and the boilers and the other connecting pieces of equipment. Pretty straightforward. There's also a different way you could do that, but let me draw it out. Well, let me show you. If you get heady on utilizing this program, you could also file, open, and have a mechanical room already built for you because you have your library of projects already started, right? So I could use that. So keep that in mind. You know, I'm trying to make you guys think outside the box. Folks, I should say, instead of guys, I should say folks, well, whatever. I don't want to exclude anybody, but anyways, I could have done something like this. So let me just see if I can close that for a second. And let me start from scratch. Whoop, where'd it go? Here we go. One of the first things I recommend you could is to make your sheet of paper the size that you want. Okay, so if you are thinking down the road that you may want to include this in your MEP file, you may want to make it a little bigger sheet of paper. So I'm going to just file. Unfortunately, if I go to page setup, I don't have access to a bigger sheet because of my printer that's defaulted in. So I'm going to go to File, Print. Instead, under Printer, I'm going to choose a PDF writer, go to Properties, Advanced, and now I have access to some bigger choices here. For this one, I'm just going to use a C because it's not that big, so you can see it a little better. And I hit OK. And I hit OK, and there's my bigger sheet of paper. And when it asks if I want to save it, I just hit cancel. And now you can see I have a bigger sheet of paper. So let me start adding equipment, right? My mechanical room. Well, the first thing, if you remember back to the little spreadsheet I showed there, was a cooling tower. Well, I happen to know the icon for a cooling tower is right here. So I click on the bottom one there, and I'm going to get this picture. I think today I want to use, what picture do I want? I guess I'll use that picture right there. How's that? Again, really the picture is your choice. The information stored in the property box for the picture are pretty much all the same. So if you open it up, you can see that, let me get up to the key data tab, that all of this information here is the same, and you would change some of that, and I will do that as I go. So the next piece of equipment I'm going to get is a boiler, right? I know I have a boiler, and instead of choosing one of those, I'll just get a condensing boiler and put it on the screen. Now watch what I'm going to do here. I'm going to put it offset because I know I can very quickly line them up nice and quick. But look what happens. This piece of equipment I got to scoot down. So sometimes when you start using alignment tools, things don't line up exactly like you think, and you might need to move them around on your own. So just keep that in mind. It's pretty easy to do, but nonetheless, you may end up having to do that. So there's my boiler. It's going to be on a primary secondary, but this tower is going to be tied right into the two pumps. So let me go up to this green icon up here. I did have to say that, green. And I'll get a vertical closed coupled pump. Put that over here. I want a second one. Put a second one on the screen. And watch this. If I bring up the property box, notice that there's no suction diffuser. I think we talked about that in one of our previous webinars about having a piece of equipment on the suction side of the pump to help get the proper straightening flow in there. So in our case, a suction diffuser, if I bring up the property box of the two pumps and I scroll down here and click on suction diffuser and hit check mark, boom, it adds a suction diffuser for that pump. Pretty neat there. So let's see, what else do I want to do? Well, let's draw some pipe here. So I'm going to come out of the cooling tower. Notice I can just put my cursor right on that arrow, left click and release. You can see me zooming in and out. I have a wheel on my mouse. It's little psychedelic there. That's not part of necessarily the presentation. Now watch what I do here. I just find this is easier. I go to the furthest one and connect. It's a little easier that way, and then I find it. Then I can just make this connection a little quicker, a little easier. So that's just how I like to do it. But obviously, you can do it any way you would like. So just keep that in mind. So let me add a couple of pieces of valves here. So let's see. I've got a control valve. I click on the down arrow. Maybe I'll get a ball valve. Now watch. If I click it in here, boom, it jumps right in and puts that on there as on that piece of equipment. I can get another one. This time I don't have to click on the down arrow. If you remember, it remembers that picture, and I can drop that in as well. So pretty straightforward in that regard. Sometimes I have to take a break to get a drink of water, so bear with me there. And I can also click on the down arrow, maybe get maybe I'll get a butterfly. Is that the one I want? Yeah, I think that's the one I want. And watch it, I can click that and put that on here and get a second one and put that on right there as well. Oh, I'm a little anal here. I want to line these up. So I'll just click on them, click on this one and click on this one and use this bar over here and line them up so it looks nice and neat. Make this a little tighter. Boom, look at that. Making my mechanical room look pretty good here. All right, so now I'm going to tie in my boiler. All right, so let's see. This is going to be coming in here, so I'm going to go like this. Now watch this piece of pipe here in a second. When I tie this in, I get some dotted pipe. This program does not like dotted pipe. So you have to think this through. And this is a good friend of mine used to call this the magic pipe. So you really have to think this a little bit. So let's see. It's dotted because it needs you need to tell it the proper direction of flow, right? The solid dark line, the solid black line, knows the direction of flow. But in this piece of pipe, it's a little confused, right? The software is confused. So watch, if I bring up the property box, well, let me bring up the property box of a solid piece of pipe. And notice under flow direction, it says automatic, automatic. For this piece of pipe, it says automatic, but it needs to be changed. Well, for cooling season, and this, when the software is designing when you're using a software to design a heat pump job, we think about heat pumps and some are on, some are heating, some are cooling, so it's not hardly ever at max. But this software designs the piping system as if it's all cooling or all heating. So that's how you have to think about it when it comes to flow. So let's think about the cooling tower, the cooling water coming to this point. Well, it does not need to go down here to the boilers. So if I click on how can I get it to bypass that? Oh, I can click on this right here. It says flow from right to left, right? So the cooling water flow, cooling season flow will always be from right to left. Now, if it was all heating, if you listen to some of our other presentations on decoupling and whatnot, the flow can actually be in both directions. It can be in this direction or in this direction. Depends on what boilers are on or how many are on or whatever. So if I click on that down arrow, I need to type in dual and hit OK. So, if anyone has more specific questions on that, I can answer them offline or send you some write-ups on that. But nonetheless, you do have to think that through a little bit to kind of get yourself through that. So let me add a little pump to this one here. Get another vertical. Now notice the pump is the flow on the pump. You can tell by the arrows is going right to left, but I'm going to put it right here. And when I get close to it, boom, it jumps it and it turns it and has it go left to right. Pretty straightforward there in that regard. So that's something to consider. And then maybe I'll put a valve on this other side of it as well. I don't like that valve there. Maybe I'll put it on this side, just so I have a valve. I guess I could put a shut off over there, but nonetheless, you can see how easy it is to add the valves as you go. Let's see, what else do we want on this? Oh, maybe I'll put in an air and dirt separator. So I go back to the Hydronic tab. I scoot around here. Here's our air separator. I'll click on that down arrow. And I like the inline ones, the high efficiency air and dirt. It happens to be a Takeo model 4900. So I'm going to put this in here, and boom, it's going to jump in and jump on there. And then the last piece of equipment will be an expansion tank. And I'm just going to get the kind of like the Cadillac, the full bladder one, put that on the screen and tie that in as well. So there's a head start for my mechanical room. Pretty straightforward there. One last piece of equipment I'm going to put on here is another valve. And it's going to be this multi-purpose valve. Put that right here, and then I can connect that up. Get a second one. Maybe I'll put that way out here as well, and I can connect that up. Notice, watch what happens when I get close to it. It'll jump in, so you don't have to worry about lining it up that much. And just because it's getting a little close here, I'm going to move this down just a little bit just to get it out of the way to give myself some room here. So there's a quick start to my mechanical room. And like I said, right now you could go ahead and create a little library or spend some time and create a library and detail these up as much as you would like for your projects. A mechanical room for a cooling tower, one boiler, one tower, or whatever in that regard. So just keep that in mind. And if you ever did want to do it for a heat source sink, you could use a well ground source, and it does not help you design the well, but you could represent that well there and start putting stuff in that regard. So keep that in mind. Rich, before I start taking off, has anyone typed in any questions yet?
Yeah, a couple. Just as a clarification, someone asked, can I get a copy of this video? And you might have missed the introduction. We are recording this presentation, and it should be available roughly 24 hours after the end of this presentation. So tomorrow, probably early afternoon sometime. You should get an email from Log Me In, which is the company that sponsors or creates the GoToWebinar package platform. And you'll also be able to download the certificate for your professional development hours credits. A couple of other quick questions came up. Someone said on the expansion tank, I presume no flow arrow. Can you zoom in on the expansion tank, Brett?
Yep. Yeah, there is no flow arrow on the expansion tank because it's really, there's no water in there per se, or there is some water, but there is no flow arrow. It goes both directions at different times. But yeah, correct. There is no flow arrow in that one.
Okay. Let's see. There was another question here. When the program sizes the lines, can you override the diameter, make it smaller? And if so, how do you do this? That's a great question, actually.
Yes, that's a very good question, a super question. It's a very common question. And can we table that one? Well, here's how you do it. If you go into a piece of pipe and double left click on it, see where it says diameter? Well, right now, nothing's connected, so it's not showing any diameter number. What are we having for lunch, for dinner tonight? Let me get rid of that. You would check in this box and type in the diameter you want. And so once we do the connect everything up, I will go back to that and make sure we do that. But yes, the answer to your question is yes, and that's how you do it.
So those that covers most of the questions that are out there right now. Brett, why don't we continue along and see if a few others pop up.
Yep. And by the way, in addition to the taping email that you're going to get, if you go to the TACO website and click on TACO Tuesday webinars, here's where you can register them. So some of you may have been here to register, but if you go at the bottom, there's a library of the webinars that any previous one, that's been recorded. And then this one will be in that library down the road as well. So just keep that in mind. All right, so let me get back to work here. So I've got a good start to my mechanical room. I'm pretty happy with that. I can connect things up. And now I'm going to start building my first a floor. And so I want to go get a heat pump. Well, I know based on experience that the hydronic heating, cooling, imposed load, if I click on that down arrow, I can get a heat pump. So I'll click and put it on the screen. And I want it to face in the up direction. So I'm going to right click on that, and I'm going to rotate it left. So it is in that direction there. And then I'm going to get a little fancy here. Well, sort of fancy. I am going to add some components to it. So when I copy and paste, those components are already there. So I'm going to go get a ball valve. Let's see, I got to make sure I do this correctly. And again, if you have a library of stuff after you make one of these, it makes it a little easier, right? I'm going to kind of tighten that down. I'm going to go get a balancing valve. Click that down, scoot it over. Some of you can probably already see, because you're way smarter than I am, that what I'm doing is making a common one, a common detail. So every time I copy and paste this, it'll be the same looking one. So that's why I'm doing this. Oop. Copy, paste, pretty straightforward. And then I can go ahead and connect this up. Right, like that. And then just because I want to make sure they're lined up, I'll just do that there. And now, let's see, I got these, I can copy and paste this, and I'm going to think ahead. So I'm going to double left click on it, bring up the the property box of the imposed load, click on description. All right, I'm going to override the identification. I'm going to call this unit A, go back to key data. And I know from that sheet I wrote up that unit A has 36,000 BTUs. There are some other numbers on here you may want to adjust as you go. I'm going to leave them all as they are. The component head loss, right? So it's going to use 15 feet. Some heat pumps have that much, some don't. So you may have to adjust that as you go through your projects. The delta T, this is kind of small. So, well, let me just show you how easy it is. I'm going to change it to maybe a little greater delta T there. And then the coefficient of performance and the EER values, they can be adjusted as well. And they do affect the heat of absorption and the heat of rejection of the unit. So these values are what show up here. Watch what happens when I hit OK. 25.7, 48.3. That's what shows up on the actual heat pump for what the coil and what the water, the cooling tower and the boiler have to take care of. So now I can just copy and paste that. There's a second one. And I can get kind of fancy here and copy. Before I do that, let's try to line these up here. Us mechanical engineers, we really like things to look nice and neat. Well, you know what? Another way to make things look neat is to go to schematic grid. And so that way, when I copy and I paste, I can kind of line them up pretty close without having to hit the alignment. Because watch what happens if I go like this and I've activated them all and I hit this alignment, see what happens? So here's a lesson to remember. Remember, you like that word? I pronounce things funny sometimes from the north of Boston here. When you attach pipe to it, the alignment tools aren't as effective. So just keep that in mind. Thank God for the big undo, the big eraser. Then I can paste two more and put them down here. And there's my, whoop, I put them in the wrong spot. So I let go. Sometimes I talk and don't pay attention. So there's my 6 loads. And, you know, I can draw a box around them. I can kind of locate them. I'm always trying to think, you know, from a drawing standpoint to line them up so it looks pretty neat on my piece of equipment or on my piece of paper. So now I can connect. This is the top floor, right? Or the 5th floor, whatever you want to call it. So let's see here. I'm going to come out of the pump, one of the pumps, and I'm going to scoot over. And what I like to do it this way, okay? I like to go to the furthest one out and connect it and connect them up like this. The reason being is, this is some friendly advice here. You can very well, obviously, connect it like this instead to the first one. But I just find it's a little harder and confusing because sometimes when you start connecting from the elbow, see, it kind of draws it in a different direction and it gets a little funky. So like I said, I like to go to the furthest one and then connect them up, and it's just easier. Right? Anytime I can save time and have a shortcut, that's what I like to do. So just not a shortcut. I'm not saying a shortcut, but time savers, right? I like to find time savers. So I'm going to do a direct return, which means the first one is the last one. So I'm going to come right out of that, go back into the cooling tower. So this might be a little harder to balance the overall system, but it really depends on what you're going to be, what one you're going to be doing. This is probably the least expensive of the two. Direct return, and there we go. See, sometimes when I'm drawing pipe, it kind of takes away from the presentation, but you can see how easy that is. Very, very easy. Now, knowing that I put in all unit A's and I need a B's and C's, I'm going to bring up the property box of these two. And I know unit B is 24,000. 24,000. And I'm going to change the description to unit B. Hit OK. And then I know these two were unit C's. Unit C's. And these were 30,000. Notice I didn't have to put any commas in there or units. Just keep that in mind as you go. And then one other piece of equipment, I'm going to put another valve on here. The more I like to add as many balancing valves as I can. That's really a personal choice on your designs. But the more we can help the balancer with the valving, the better. So that's what I'm going to do. So there's my top floor, my 5th floor, mechanical room. Now I can copy and paste and make my other 4 rooms. I think it's a 5-story building. I should be able to remember that, but us old folks, we forget things so quick, it's unbelievable. So there's my next floor. Paste another one down here. Now notice this sheet of paper is, we're going to go into a second sheet of paper, but I'll show you how we can show it all on one sheet, or I probably could have used the D size. Well, let's see what happens if I change it to D size. So what do I have? 1, 2, 3, 4. One more paste. And there's my 5th floor right there. You can see I'm lining them up by eye pretty close. And now I can come down to this one and scoot up here. Whoop, 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 whoop. There it is. Tie it in. And then go ahead and tie in the other 3 floors. By the way, this graph paper-like looking background does not print out. It does not show up when you print this out, if you happen to print this out. So keep that in mind. Now I have to do my return. See, this is a little confusing over here. So you got to make sure you go to the right one. And again, I'm going to go down to this one down here, click on this one, and whoop, get up to this return, and now tie in my other 3. Now see, this elbow, this gets a little tricky, so you got to be careful on this. Right now the software is confused. You can see it has some long dotted pipe. That's even worse when you see that. That means something needs to be connected. But I'm going to zoom in here, and I just left clicked once, and notice, unless I go vertical, you don't see that piece of pipe. So sometimes people double click and they actually put in so what you need to do is left click, scoot away a little, and then left click again. Oop, there we go. Yeah, see, it gets a little confusing sometimes, so you got to be careful there when you're starting off at an elbow, right? This looks like an elbow, so just keep that in mind. I just until you get used to it, until you do it a couple times, you'll understand what I'm saying, but it does get a little tricky, so just keep that in mind. Notice my software is not doing any automatic calculations. That's because if I go up to edit, it's in manual recalculation. I do recommend you put, once you start doing a design that's a little more complicated, and even this one's kind of simple, you will put it in manual recalculation. That way it won't try to make changes every time you add something or connect something. And it can slow down the program just a little bit because it has to think all the calculations through. So that's why it's in manual recalc. So you're not seeing any calculations here as you go. Oh, notice, I almost forgot. I got to connect in my second pump. I only connected one in, so I got to make sure I do that. And there's my pumps. Now see what it shows on a heat pump? It shows worst case for cooling and worst case for heating. I mean, obviously we're going to probably most of the time be running in the middle there, but that's what the software does when it is doing a heat pump calculation. So just keep that in mind. Let's see what happens if I change the paper size here to a D size, because that's usually probably more what an MEP would be using. There we go. That looks a little better. Hit cancel, fits on there nice. And then because I like it to line up, I'll just move it over to the middle. I see I can just draw it around. I can move it all around. So very quickly, I've done that. Let's answer that question about pipe diameter. So first off, I want to display the pipe diameter. So hopefully everybody remembers how to do that. I hit Control A on the keyboard, right click, connector annotations, diameter, and there's all our diameters shown for us very, very quickly on the sheet of paper. So I'm going to get rid of the background there. So maybe you wanted to change this piece of pipe to 3-inch. You double left click on it, check that box, type in 3. Watch what happens to these values here when I hit 3. It shows you the new values. So you can see that you're going to get quite a bit of head loss in the maximum flow in the cooling season of 240 gallons roughly. So that's why it went to a bigger size piece of pipe, as well as the velocity, right? The velocity is a little high, but nonetheless, that's how you could change that. And if you wanted to change more than one piece at a time, if you click on this one, hold the shift key down, click on this one, and click on this one. Oops, I didn't hold the shift key down, right click, property views. Now I have the pipe for all 3 of those, and I could change the diameter for all 3 of those if you'd like. I'm not going to do that, but you could do that if you'd like. So if you remember from previous presentations, one of the other pieces of information you have to put in, right? We put the loads in BTUs per hour, but it's pipe lengths. Now I have to put some pipe lengths in. So I got to do some thinking or estimating or whatnot. In the example we did a few months ago, I kind of just put it in so you could think about it, so you could see how to do it. Now I got to think about the project a little more. So I'm up on the roof, and I'm coming down to the 5th floor, 4th, 3rd, 2nd, 1st. Well, roughly 15 feet between floors. So I'm going to go like this. I'm going to click on this piece of pipe. hold the shift key down, click on this one, click on that one, click on that one, that one. There's different ways to do it here. Right click, property views. I want all the pipe, and I'll put in 15 for that. So now I've got 15 feet for those pieces of pipe. Now let's see, up here, since it's all the same diameter pipe, I'm going to estimate from the cooling tower over to the pumps and all of that. I'm going to put in maybe 60 feet of pipe. And again, obviously, it's all based on your mechanical room. Here's my my boiler loop here, and maybe for this piece of this area here, I'll just put in 30 feet of pipe for the near boiler piping. If the boiler that you're ordering is coming with the pump, you don't have to schedule that pump. You can double left click on it, and under coordination, you can uncheck equipment schedule. So now that pump won't show up on the equipment schedule. So you don't want to double order or whatever. So you know, you could do something like that if you'd like. So keep that in mind. So I've got my piping for the up here. Go ahead, Rich.
So Brett, we have
questions?
a couple of good questions. Actually, an excellent question came up, which I
Super.
So Ray says, when I drew in the heat pump pipe, it automatically inserted a pump for each heat pump terminal unit. How do I control that? That's a fairly common issue. Yeah.
Yes, it is. Yes, it is, Ray. Let's see. How can I best explain this? All right. I'm going to add a heat. I'm going to put a heat pump. I'm going to copy. Just so everybody can see this, I'm going to paste the heat pump right here, and I am going to click on Edit. So Ray and everyone else on the call, if you look under Edit, near the bottom it says TACO Load Match Design, Primary, Secondary. If that box is checked, what happened to Ray is what happens. Watch, it drops in a pump and it ties in the piping with a twin T and stuff like that. We're going to talk about that type of design shortly in the last in a few minutes, but that's why it did that, Ray. So if you want the software not to automatically draw in that pipe, you got to make sure that there is no check mark near TACO Load Match Design, Primary, Secondary. So hopefully that answers that question. Anything else, Rich?
Yeah. So another person said, are there any warnings built in for too high a velocity in the piping? Do we get any kind of warning or alarm when we?
You do not. Well, the software automatic. I'm going to go back to this piece of pipe again, right here. Click on it. There are no warnings per se, but the software if you leave this box unchecked, it calculates values that are within HVAC standard practices, Hydraulic Institute or ASHRAE standard practices. So it uses the charts associated with pipe sizing that actually in 2 weeks we're going to go over some of that in another webinar. So there's no visual warnings per se where it says that you got too much flow through that piece of pipe. You do need to have some ability to understand the design, but if you let the software calculate the values and display it, you rest assured that you will be using numbers that are well accepted within our industry. Hopefully that answers the question, but that's kind of the best we can do on that one.
Okay. Another question popped up, Brett, which is a great question. It says, where is the elevation head calculated or accounted for?
Oh boy. This is so this is a closed tower. This is a closed loop system. So the head loss for that pump does not need to, what goes down comes back up with the pressure in the system, and it does not need the elevation of it. If this was an open tower, you could actually add some head loss right here, component to tower top, and add for the elevation. But the elevation to get from the roof to the first floor and back up to the roof, to the mechanical room, does not need to be, the distance, the pipe length needs to be taken into account, but the 100 feet or 75 feet, whatever it is, height of that building, that elevation does not need to be taken into account. Do you think I explained that properly, Rich, or not?
Yep. Nope. Someone, I think they got it. So let's
Okay.
continue, and I'll continue to monitor the questions.
Thank you. Let's see. So well, right now, you know, it didn't take that long. We have a pretty good hydronic design for our 5-story heat pump project. You know, with a nice piping system, a lot of information associated with this. Matter of fact, if you want to get fancy, I right click and go to text annotations, and I can type in, how do you spell FIFT? F-I-F-T-H, I think so. Sometimes us engineers and spelling aren't necessarily in the same category for properness, but nonetheless, you can. And then I can type in 5th floor right there. You know, add a little pizzazz to my drawing, and then watch, because I'm lazy, I can type in 5th floor 3 times. Sometimes when I do things, I forget that I got to do a little work here without talking that much. And then I can click on this one, and obviously there's different ways to do it. I just, I look for shortcuts. Right? The more information, so it depends on your audience, right? You think about who's going to be looking at your design, you know, the contractor that's going to be bidding it or pricing it up, or whoever your team is. You know, you want to make sure you can do that very quickly. So here we go. Maybe you want to put it near the piping or whatever. So I just keep that in mind. All right. So let's the next part of a project could be selecting equipment, right? So you might want to start selecting equipment. So one way to do that is anything with a shading under it. I can double left click on it, click on the word selection, hit select, and hit OK. And notice that piece of equipment has been selected. Or you can globally select all the equipment by hitting this icon here. I think it says select equipment, and that's how quick your equipment has been selected. I didn't utilize a lot of the icons that have equipment that would be selectable, but nonetheless, I did use a few. It happened to be the Taco stuff. I'm not sure exactly why I'm selecting it. I do know why I'm selecting the Taco equipment, but anyways, you can use some other icons on here. As an example, look at all the boiler manufacturers that are in here that you could use to select some equipment as well. There was something else I wanted to show. Oh, here's a pretty good handy screen. If you double left click on the pump, I always recommend to people to go to the summary tab on the pump property box and make sure you're comfortable with this head loss. It's showing you 2 worst cases, right? The head loss for heating, head loss for cooling. But just take a look at it and make sure you're comfortable with these values. There's the major components. Here's my minor components. I got some valving in there. Unit B, that control valve is pretty high. Maybe we could take a look at that and see why. I'm sure it has to do with the diameter. And then, just as important, look at where'd it go? The piping, and make sure you see some piping called out. Make sure you got your values in there for piping. And let's see. So a Unit B control valve has got a pretty good size head loss. It must have to do with the and you can, it has an automatic in there. You can override that if you'd like. I'm not going to get into that much detail, but you can change that value. Well, watch, if I type in the 10 here, all of a sudden that one has 10 now instead. So just keep that in mind. So now I've selected my equipment. I've created, I can create my schedule. So if I go up to File,
Say, Brett, before
Open
we go
court.
into
Yeah,
the schedule, a
yeah,
couple of quick questions.
yeah.
Let's see, is it possible to convert the units to metric?
Great question. The answer is yes, if I can remember how, because I don't do it that often. You know, Rich, back when I was in grammar school, what 10, 15 years before you, they told me in a few years, in the United States, we were going to be in the metric system. You remember the teachers telling us that?
Well, yeah, but I don't know. I don't know. I thought you were, I thought I was 10, 15 years younger than you.
That's what I said. That's what I meant to say. Yeah, I was in school. Well, anyways, metric system. Double left click, bring up the project property box. Okay, so again, I went to a clear area in the screen. I double left click. I brought up the project property box. Near the top on this side, left-hand side, unit of measures, metric. I hit OK. And then I have to recalculate because I got it in manual recalc. And there's your metric units shown. I think that stands for millimeters. What do you think, Rich? Double M, pretty sure?
Yeah, I'm pretty sure.
And to further confuse things, if you double left click and bring up the project property box again and scroll down to coordination file options, and I can say use both unit of measures and hit OK, and then recalculate, you can look, now we can all learn there's both unit of measures. So you can do that very, very quickly if you'd like. So just keep that in mind. I am going to undo a couple of times here to get back to where I was, hopefully with the calculator. Any other questions, Rich?
Yes, this one is an excellent question. This is one of the things that you and I have talked about. It has the limitations of the software. I'm going to read the question. Can you apply diversity factors so that the pumps are selected for something closer to block loads as opposed to the sum of the peaks of the equipment loads?
Here's what you can do. If I click on the pumps property box and go up to the key data tab, flow portion 100. You can change that flow portion to a lower value if you would like. Let's see what happens if, excuse me, if I type in 80, those values right there, if I hit OK, excuse me, and hit the recalculate button, you can see, and it shows you what values you're using there. Or I just hit undo, or you can go over to the cooling tower. This is probably where you might want to do it. Load portion 100%. Unfortunately, you can't go higher than 100%, but since it's the sum of the peaks is what we're showing, great group of words there, sum of the peaks. I like that. You can change the values here to reduce that down if you'd like. So that value is a little less in that regard. So it's really up to you where you would like to do that. Notice if you do it here, it doesn't show it over here, so you'd still have to change it over here. So, but the answer is yes, you just got to work with it a little bit.
I think for clarification purposes, one of the things that the software does not do, I believe this is true, that you can change the percentage of the capacity for the pumps or the cooling tower or the boiler, but it does not physically change the pipe size.
Correct.
Because the pipe size is based on the total load, so it does not take any diversity for sizing the pipe.
Right. Well, let's verify that, Rich. What do you think here? So I'm going to the pumps and changing that. And right now, before I hit, it shows a flow of 129 and 245. It still shows the maximum for the pipe flow going through there. Correct.
Yeah, so that's one of the things that we have to be aware of when we're doing these sort of calculations. The software is not smart enough. If we had, say, one pump, for an example, If we had one pump and we put in 10%, it'll select the pump at 10% of the flow, but it's not smart enough to know that the pump's not big enough to handle the 100% of the flow. But
Yeah,
it
you do
will
have to
keep
be
the pipe size the same.
correct.
Okay.
So file, coordination file options, equipment schedule, and just to reiterate, we've said this on our previous presentation, you can save this to AutoCAD. Rich actually showed you what it looked like, and it is a layered accessible drawing. So just keep that in mind. I hit OK, and I go to File, Save As, hit Save, and my schedule has been created very, very quickly with the pieces of equipment that we worked out there. So you can do that very, very quickly. There's my schedule. Let me show you a quicker way to do what we just did. File, New. I'm going to get a new sheet of paper. And I am going to, again, make a bigger sheet. If it's a straightforward project, this is a potential way to save even more time utilizing this software. Wizard. I click on Wizard. I click on Hydronic. I went to System. Let's answer some questions. All right. It's going to be a direct return two-pipe system, heating and cooling, combined schematic. All right. So it's a heat pump job. Number of loops, 5 loops, right? It's a 5-story building. Horizontal, right? The mechanical room's top left. Hit next. Number of loads, 6 loads. I'm going to show them all below the pipe. Actually, you could show them above and below, but it really takes up a lot of space. So for this type of layout, I mean, it depends on what your audience, you know, if you think about our project, there is one on both sides of the pipe for our layout, but I'm going to show them all on one side of the pipe just to make it fit a little better. I'm going to choose a heat pump again, hit next, 2-way control valve on the outlet, and unit. I'm going to type in the same value for all of the units, right? 36,000. I put in a boiler. Here's that heat source sink, so you could have used that in a cooling tower. Put in 1 boiler, 1 tower. You can adjust the temperature. This temperature is a little low, right? But probably 85, 95 is more the range, but I'll just leave it like it is. Again, primary, secondary. I'll use this Taco hydraulic separator instead of that bridge. I'll put in a piece of equipment that could replace the bridge. And then I'll just manifold primary again. 2 pumps attached. Let's put in the frame mounted end suction this time. This is the pump attached to the boiler. I'll just leave that alone. Expansion tank, air separator, hit finish. And there's a even quicker way to do your project utilizing the wizard, okay? The boiler temperature is a little high, so you may have to adjust that. So just keep that in mind as you go. You got to do that after the fact. And again, Control A, right click. Where is it? Oh, connector annotations diameter. There's all our diameters shown very, very quickly. Don't forget, you got to add in your pipe lengths, right? We haven't done that. Now, a little earlier, someone asked about when it attaches circulators. Well, watch this. Watch what you can do with this. Here's a potential design savings, right? System savings. If I go to System, and I'm going to draw it up because it remembers. This time I'm going to put in a Taco load match single pipe, right? And I think we will have a webinar on that down the road so we can learn about that. But it remembers all your answers. So I'm just going to scoot through. And here's a single pipe system instead. And if I hit this, so similar to the question that was asked, notice instead of a control valve and or a balance valve and maybe some shutoffs, this one's having a circulator to guarantee the flow getting into that heat pump and a lot less piping. a lot less piping. You can send this to a contractor and you can have them price them both up side by each. And then very, very quickly, again, Control A, connector annotations, diameter. Notice the single pipe has the same diameter all the way across, 2.5 inch. The two pipe system starts out at 2.5 inches, and then it reduces as flow goes into the heat pumps, right? And then it gets bigger as it comes back. So, but the first piece of pipe on a single pipe is the same diameter as a two pipe system. So keep that in mind. And notice I'm on 2 sheets of paper here. I could move that up, or if you go up to edit, schematic scaling, if I type in a value here, it's not a scaled project, but all that does is reduce it down so it's on 1 sheet of paper, you know. So keep that in mind. You can start doing that very, very quickly as you like to go. So and normally the head loss on these systems for a heat pump system is a lot less than for the main pump than it is, probably roughly half as much. So that regard. So if you use that wizard, you can really kind of get a quick design very, very quickly. There's my 5-story building. Looks a little different, right? I connected the pipes up different. Keep that in mind. Let's see what it looks like if I go to system again. This time I'll choose reverse return. Let's see what it looks like when we get all the way to the end. And there's just a different type of piping system, so you can kind of see how they look a little different as you go there. So just keep that in mind. So something to consider. Any other questions, Rich? I'm getting close to the end here for a change.
Yeah, we have some great questions. One very quick one. I don't know if I know the answer. You might know it. Is the software available in Spanish?
I do know the answer to that. The answer is no, unfortunately.
Well, we'll have to get together with the
The
developers of the
HVAC
software.
guys.
Yeah.
Yeah. I just to make sure people realize out there, although this is a program you can download from Taco did not write the software. We're partners. We have a partnership with the folks who wrote it, and they are HVAC Solutions. So if you go to the website, they can give you more information as well. So, but Taco did not write the software.
Another
Couple
quick
more
question.
questions, Rich?
Yeah, I'm not sure if I asked this already, but how did you get the pipe diameters to show up? Could you go
Great
over that one
question.
more time? Yeah.
Yep. Let's see if I can. I'll zoom in. Well, you know what? Let me get back to this other project because it's just it's a little easier to maneuver with just one. So let's see if I go like this. All right. So notice I don't have any no pipe diameters are shown. Okay. If you need to activate the whole drawing. The easiest way I find to do that is hit Control A. So when I say activate, you can see all the green boxes, grippers, whatever you want to call them, right? So now I'm ready to do something. I right-click on my mouse. I go up to Connector Annotations, and I scoot over, and here's all the annotations I could display, and I'm just going to display diameter. And if I zoom in, all the pipe diameters are shown. So hopefully that answered that question.
Yes. Okay, a couple of others popped up. Can this software be used for domestic water diagrams?
There is a domestic tab. Unfortunately, the Hydronic version of the software that we offer to the industry cannot do the domestic. In order to do the domestic, you need to upgrade. Oops, what did that say? It actually said it on there, didn't it? You need to upgrade to the Pro version. You need to purchase the Pro version. This version is free. The HVAC Hydronic version that allows you to do hydronic designs, you can download from our website free of charge. The Pro version allows you to do domestic and other stuff up here as well, steam and air side systems. You need to go to their website to download it. Anything else?
Yes. Is this layout exportable to AutoCAD? I think you covered that, but it's worth going over it again.
Yes, the answer is yes, it is. In order to do that, you need to go to File, Coordination File Options. I don't know where they came up with this, but this is where you go. Coordination File Options, you click on that. It brings up a tab in the property box of the project. And notice where I saved it to an equipment schedule. If I click on Schematic and hit OK, it'll save it to and I hit Save. It saves it to a DXF. Unfortunately, notice right here, Project Schematic DXF. I do not have a viewer on this laptop. Don't get me going on my computer situation. It's being corrected, but I've been limping along here. But anyways, currently on this borrowed computer, I don't have a way to show that to you, but you can do it. Oops.
So Brett, someone asked, is there a limit on the pipe size? Hold on. Nope, that was my baby doggy.
I heard that. Is that Jenny saying hi to everybody? Hi,
Yeah,
Jenny.
that's my baby dog. She's just 1 year old this month.
Yes, there is. 144 inches or 12 feet in diameter. Most HVAC systems are a little hydronic systems, but especially in North America, are smaller than that. But probably in some countries, maybe 12 feet isn't big enough. So there's the answer is yes, 12 feet. Isn't that 12 feet? 144? 12 times 12 is 144 still, right?
Yeah.
Yep.
Okay, so this one's quick and dirty. Brett, can you demonstrate how to draw a second pump for the boiler?
Yep. So I zoomed in on the boiler. I right click, hit copy, right click, click paste, put a second one in. And notice right now, because I don't have this, or I didn't, it's in manual recalc. There it is shown there very, very quickly. So pretty easy to do.
Okay, is it possible to use this software for open systems such as cooling towers in a chilled water system?
Yep, you can do that. The picture for the tower here would be an open picture instead. And again, they almost look the same, but this would be an open tower compared to this be a cooling tower. Like I said, they're the same, but you may have to put in the value for the head loss here. So the answer is yes, you can do that. You would just have to adjust the value. One thing, Rich, this question came up after our MTSH webinar a couple weeks ago. This software does not do MTSH calculations. That's still something that you have to do offline or manually. It does not do MTSH calculations.
Okay, another question, which I thought was a great question. I'll make sure I'm reading it properly. Oh, will the software make a list of fittings and products to quote for the wholesaler? In other words, can it create a bill of material?
It does create a bill of material. Hold on, File, Coordination File Options, Bill of Material. Hit OK. Save your file again. It does create a bill of material. Unfortunately, somebody has to count the fittings to input them into the bill of material, because it doesn't really know all the fittings. So you can see here's the bill of material. It'll it puts them in here, but somebody has to actually count them and add in more. I don't think this is going to be as 100% accurate as you think, but nonetheless, it does do a bill of material. Allows you to do a bill of material. There could be additional ones you may want to add in there in some cases. I think we're winding down, Rich.
Yeah, I
Got
think
a
there are
couple
a few
more.
other questions, but I think that we've asked the most common ones. At this point, I would say any additional questions, I believe we can answer those once the presentation is
Yep.
finished. We'll get a list of questions and we'll probably answer those within the next week or so. But I think at this point, Brett, do you have any final things that you would like to say or do before I sign off?
No, I do want to thank everybody for their time. I appreciate great questions today, Rich. It was fantastic. It was really super questions. So other than that, I'm going to sign off. Thanking everybody. Look out for it. And if you ever need, if you send something to the TACO website, we can answer your questions. So if you get a chance to use the software, send the questions in. We'd be more than happy to answer them. I answer them on a daily basis. So keep that in mind. Other than that, thank you for all your time. And Rich, take it away.
Well, folks, thanks again for participating in our TACO Tuesday presentation. Again, on behalf of all of the TACO family of companies, we want to express our appreciation for your participation. Look forward to some of our other TACO Tuesdays presentations. We swap back and forth, alternating between commercial and wholesale residential. And I believe the next Tuesday is for wholesale residential. So on behalf of all of the TACO family of companies, Brett and myself, thank you very, very much and take care. We'll sign off for now.